Hello students, welcome to your underground METALIFERROUS mining classes. This is your second session. In our previous session, we had seen what is the definition of an explosives and classification of explosives. In your second sessions, we will be discussing about the same topic under the classifications of explosives, the difference between the low explosives and high explosives, and what is the definitions of low explosives and high explosives. And let me go into the topic. Low explosives. The chemical reactions in low explosives is called deflagrations, which is a rapid process of combustions without accompanying any shock wave, but gives a heaving effect. There is nothing but your low explosives. In low explosives, we have to know the low explosives, the basic reactions happening in a low explosives is deflagrations, and the effect in the low explosives will be heaving effect. There are two words to be remembered in low explosives. One is the deflagrations, second the heaving effect. Let's see a video to understand better about what is exactly a low explosives and high explosives.
A friend called me. It's using terrorist-related situation. Now we won't go into a terrorist how-to video. Caught fire or ignited.
See, this burning itself we call it as deflagrating.
Together actually exploded.
This is
That's a household item.
Shattering.
Now, one pretty interesting fact that was pointed out to us was that most of these household items, when mixed together, you'll notice that the smoke is a white or light color, whereas the military grade or commercial grade explosives typically have a black or darker colored smoke, and you'll see that later on in the video. Now, some of these household items require a little bit
exactly
more
what
precaution
heaving
to
is.
handle.
What is deflagrations? Here you can see the burning. This is nothing but deflagration. Let's go for, see, low explosives. The best examples of low explosives will be your gunpowder. Gunpowder, which consists of potassium nitrate, charcoal and sulfur. Potassium nitrate at 75%, charcoal at 10% and sulfur at 15%. This will be the compositions of your gunpowder. How the gunpowder looks like? See, it looks like this. This is how the gunpowder looks. Okay, now let's go to our next topic called high explosives. The reaction in high explosives is characterized by the shock wave initiated by a detonator, which gives a shattering effect. Now let's see. See, as I said to you, this particular explosives which gets initiated through a detonator, what we call it as a shock wave. It comes through a shock wave and the effect will be of a shattering effect. What is that meaning of a heaving, the difference between heaving and shattering? Heaving is nothing but which creates a crack or a fracture in a rock, whereas a shattering effect is nothing but a burst which throws away the stones or the surrounding to the faraway place. This is nothing but a shattering effect. What we could see here, the rock is exploded with a huge smoke here. This particular blasting is through high explosives. How you can conclude? Because there is a shattering effect. With high smoke, what you can see here, the rocks are thrown away. This is nothing but your shattering effect. Here, we couldn't see how it is getting initiated. It is initiated through a shock wave, but we could visualize the effect of such explosives through the picturized here, as we could see the shattering effect. Okay, let me also see a video to conclude.
Typically have a black this, but check this out. When we blew and what's a good explosives demonstration without a little C4?
See, this is about high explosives. Let me see some other.
And without further ado, it was time for the headlining act, what they call the Hollywood shot, a culmination of explosives, gas, and whatnot. I'm betting you recognize it.
Okay. We have seen what is low explosives and high explosives, the difference between them, and now we'll come within high explosives. In case of low explosives, we came to know the best example in case of low explosives is gunpowder, right? And in case of an high explosives, we have to see various other examples of an high explosives. The first, let me cover up what is called ammonium nitrate and fuel oil explosives. See, in case of ANFO, what we call ANFO, and abbreviated as ammonium nitrate and fuel oil, or a diesel oil. In this ANFO, there are two types, which is called premix and site mix. ANFO are of two types. One is a premix ANFO and the site mix ANFO. What is the difference between them is the premix ANFO means the ammonium nitrate and fuel oil are mixed in the company or in the magazine and distributed or supplied to a mine site. That becomes a premix, where a site mix means the ammonium nitrate and the fuel oils are supplied individually to this site, and the mixing of this both takes place at this site, what we call as site mix. The miners usually prefer for a site mix ANFO. The reason behind is, once the ammonium nitrate and the fuel oil mixes together, they instantaneously become an explosive mixture. That's the reason. For the safety aspects, the transportation is suggested to have a separate transportation for ammonium nitrate and separate transportation for fuel oil, other than the mixture that we call the premix. We usually prefer for site mix ANFO. Let me have a video to demonstrate what exactly the ammonium nitrate fuel oil at site mix looks like. See, the packets, what we could say is nothing but an ammonium nitrate, which is pricked at the see now, this ammonium nitrate is inserted in the blast holes. Now, in this video, we are going to learn how exactly the blast hole is being charged using ammonium nitrate and fuel oil at this site. The procedure, what we call technically as site mix ANFO. In this, we would have seen just now the red color piece. What you have seen is nothing but a booster. It connected with a detonator, and detonating fuse is being, along with detonating fuse, it has been inserted inside the blast hole, right? Now, slowly, when the booster is inserted inside the blast hole, the next packet of ammonium nitrate will be inserted inside the blast hole. But it should be pricked at the top. As been seen, number of ammonium nitrate packets has been inserted inside the blast hole. Now we are going to measure the depth of the hole. The reason is, initially we would have measured the depth of the hole, and now we are going to measure what is right now the depth of the hole, which will give us the actual depth filled with ammonium nitrate. And on the base of calculations, we are now going to pour diesel oil inside the blast hole. The ratio should be accurate. That is the reason we are going to measure this blast hole. See here, this is how the diesel oil is being transported to this site. Students, can you see the diesel oil has been poured inside the blast hole? This blast hole is called large dia blast hole, where we have already inserted ammonium nitrate along with its booster, and we have measured the depth of the blast hole after insertions of ammonium nitrate, and now we are going to filling diesel oil inside the blast hole. Now the stemming operation is going on. This is nothing but stemming, right? Now let's see how the blasting takes place. We are seeing here the shattering effect, right? This high explosives through. In high explosive, this what explosive we have used? This is nothing but ammonium nitrate and fuel oil. The chemical what we have used is nothing but ammonium nitrate and fuel oil. See, now you can see the exact blasting, how it takes place in the mine site. Okay. Hope you understood what exactly is ammonium nitrate and fuel oil, right? Students, let us go for the next example, which is called as slurry or water gels. See, a water gel or a slurry explosives is a gelatinous aqueous solution that consists of an oxidizer such as ammonium nitrate and a fuel. Typically the fuel contains additionally solid oxidizers, fuel sensitizers such as aluminium or other explosives which could be seen in a packets. Let me see what the gel explosives looks like. See what we could see a gel explosive. The gel explosives, as we have seen, it could consist of ammonium nitrate along with the calcium nitrate and the solid oxidizers and sensitizers is its constituents of this gel explosives. It exactly looks like this. You could see here. See, this gel explosives now is being attached along with the detonator. Let me see. See here. These are detonators, detonating fuse. It has been tied to this particular gel explosives and inserted inside the blast hole, right? See here. Now this detonating fuse are connected. Each hole has been inserted with the gel explosives which are connected with a detonator. Along with this detonating fuse has been tied to this particular gel explosives, right? Now let me come with the next topic. See, in case of explosives, for example, when we in our future classes, we'll be discussing about the detonators, right? we use certain chemicals for primary initiations and certain other chemicals for secondary initiations. What are these primary initiations, secondary initiations? Nothing but in a previous class, we'll be seeing a few things like properties of explosives in our next coming classes. Right now, let me teach you the primary explosives are nothing but which requires a small initiation is more than enough for this explosives to explode, which could further initiate the secondary explosives. Why a primary explosives is required? Primary, it is required to initiate the secondary explosives, right? Now, what are the few examples of such primary explosives? If you could see here, the mercury fulminate, lead acid, silver acid, lead stephanite, tetrazine, right? These are the few examples of an primary explosive. In your detonators, what we have seen up to now, the gel explosives connected with along with the detonator. In case of ANFO, we saw a booster. Booster has been connected along with the detonators. What is a detonator? Given the detonator consists of a primary charge and secondary charge. Even that detonators. Primary charge like ASA, as you have seen here, the lead acid, lead stephanite, and aluminium powder. The abbreviations of ASA means. Now, it also consists of base charge, that is nothing but a secondary charge. Means initially this primary charge explodes and initiates the secondary explosives as a base charge. What we have in detonators, every such explosive we have a formula like first primary to get initiated and then it initiates the secondary explosives. This is how we see the explosive initiation takes place. And in case of your secondary explosive, we have seen RDX, HMX, PETN. The PETN will be your base charge in your detonators, right? PETN is nothing but pentaerythritol tetranitrate, tetryl nitroglycerin, picric acid, TNT, trinitrotoluene. These are your secondary explosives. How it could be combined? See, on its combinations, amethol, which is nothing but TNT plus ammonium nitrate and other combinations. Okay, let's go for the MCQs of the day. The combinations of gunpowder is, yes, we have seen charcoal, sulfur and potassium nitrate, right? What is the exact percentage? We have seen in previous slides the potassium nitrate should be of 75%, right? Sulfur is 10% and charcoal is 15%. The right options will be your option A. The second MCQ, in ANFO, that is ammonium nitrate and fuel oil explosive, the percentage of diesel oil in mixed for the effective oxygen balance, the explosive mixture is 5 to 6%. Have you seen in the previous video what we have seen? After insertions of ammonium nitrate, we were exactly measuring the depth of the blast holes. Based on the depth which exactly gives us the calculation what is the vacant space available in the blast hole, so that we could calculate the percentage of diesel oil to be inserted inside the blast hole, right? We will come through the length measurement, we will come to know what percentage of ammonium nitrate is already added and what percentage of diesel oil to be added. Here, the right percentage of diesel oil to be given for this ammonium nitrate will be your 5 to 6% for exact oxygen balance. What happens if you give more than 5 to 6%? May lead to the misfire. Why misfire? Reason is the oxygen balance may not take place if it is more than 5 to 6%. At that circumstances, the blasting efficiency comes down and there may be a chances to go for a misfire, right? The amount of diesel oil mixed for 100 kgs of ammonium nitrate is dry season and wet seasons will be your 7 and 9. See, diesel oil, the variation in the dry season and the wet seasons will be from 7 to 9, right? 7, it is not percentage. Remember, here we speak in kgs, not in percentage, right? It is for 7 kgs for every 100 kgs of ammonium nitrate, right? What excess percent of diesel oil will lower the sensitivity of ammonium nitrate? It is 8%. If it is exceeding 7, what happens? It lowers the sensitivity of this explosive mixture. That is not preferred, right? Thank you students. We'll meet in our next class.